makes a critical difference to what you might expect to happen in the game. This is actually a multiplayer game, so we won't draw a game tree, but we can use the same logic that we've been working with all the way along. So the first thing is that there's it's going to be just a simple transaction between a buyer and a seller. Okay, the good or service being exchanged is either high quality or low quality, and the seller here is assumed to have some private information about the quality, and that private information is quite relevant to the buyer's evaluation. But the buyer isn't informed of that. Okay, it's private to the red player or to the seller, and the buyer that doesn't have that specific information about the quality. So buyers realize that they're going to have to take a gamble whenever they buy anything. They're going to have a high gamble or a low gamble, just by kind of looking out there and what's at the market, what's on sale, and so they'll work out a willingness to pay. Okay, it's a willingness to pay for a gamble. So we've been using probability-weighted averages of money to indicate what the worth of a gamble is, and that might be the case. You might want to make a little adjustment for risk, but at the end of the day, there's going to be some willingness to pay on the part of the buyers, and that willingness to pay isn't going to be as much as they would pay if they knew the product was high quality, and it probably won't be as low as what they would pay if they knew the product was a really poor or low quality. It's somewhere in between. It's like a weighted average of the values they place on high quality goods and low quality goods, at least the ones that are for sale on the market. Now, the average quality that's out there in the market, though, is not just the average quality that's out there in the population of people who might be willing but may not sell their items. Let's see how this might lead us into a vicious circle. So we've got these high quality guys, medium quality guys, and low quality guys. At first cut, the buyers are willing to pay some sort of average, but at that average, what happens to the high quality guys? They've got above average quality cars, so they're going to, or items, so they're going to withdraw them off the market. After a while, the buyers are going to learn about this, and that's one of the key assumptions. Can they actually learn something about the quality that's left in the market? And they're going to find that there aren't any high quality goods left, so they're going to lower their willingness to pay even more. Okay, and that'll be somewhere between the medium quality goods and low quality goods. But then, once they lower their willingness to pay, the medium quality willing to goods guys are going to think, hey, I don't want to accept this poor prices that are out there in the market. I'm going to withdraw my quality out of the market, and we get this vicious circle or cycle downwards in what's actually available on the market and the price that it can command, all because of this private information problem. Let's have a little closer look at it in a simple numeric example that's in the text. And almost any game theory text, called the Lemons problem. So we're going to be thinking about used cars here, but it could be houses, bicycles, furnishings, body parts for that matter. Anything physical. They're going to have variations in quality, and there's buyers and sellers. Now we're going to think of car market, and used cars are worth anywhere between $1,000 and $3,000. Now, whenever anybody says this is how much something is worth, at the back of your head, automatically, without question, should spring worth to who? Okay, so we're thinking there's potential buyers out there. They've got willingness to pay for various kinds of cars. Anywhere between $1,000 and $3,000 is the range of values at which they would be willing to pay. Okay, and that's because there's a range of qualities out there in the market. Okay, and the buyers are willing to pay for quality if they knew it, but they don't necessarily know it. But supposing that we let X be the worthiness or worth of an item to a new owner, and in that case, let's suppose that that particular item is worth $200 less to the current owner. So we have a car that maybe to the owner is worth $2,500, which means a new owner is willing to pay $2,700 for it. Okay, there's always a $200 difference between the value to the current owner and the value to the new owner for any car with where X is the value to the new owner. Okay, so the idea is that there's a lot of qualities X out there in the market. The owners, the current owners and potential new owners have valuations of it, and the current owners value it less. Perhaps that's because they know more about it, but they value it less than the blue guys. And we suppose there are lots of buyers and sellers of any particular quality. Okay, so what tends to happen there is that for any particular quality, if we knew what it was, the transaction price would get bid up to the maximum amount that the buyers are willing to pay. So we just keep that down as a little heuristic. Now, supposing that information about these items was symmetric, that is, both parties know, this little stamp in the forehead thing, the blue guy comes with a stamp of, say, this car is worth $2,800 to me, and the red guy says, well, this is $2,600 to me, and they'll make a bargain because 28 is more than 26, okay? But the difference in the values they place is always going to be $200. But the car should trade, that car of that quality or that value to the buyer should trade somewhere between X, the maximum this guy's willing to pay for it, the owner's willing to pay for it, and the X minus 200, which is what the seller would supply for it. A little different with asymmetric information. Because you have to ask yourself what exactly is on the market. So let's suppose that all the cars from $1,000 to $3,000 on average are out there. So let's suppose that all cars from $1,000 to $3,000 are out there, and an average willingness to pay, if they're all kind of equally distributed here between $1,000 and $3,000, the average willingness to pay will be about $2,000. So supposing that that's what the potential buyers of cars start buying cars for, will that be at $2,000? Who is actually going to be selling their cars? The seller looks at the price of $2,000, and if he's an owner and his price is $2,100, or just anywhere more than $2,000, then he's not going to sell it at the price of $2,000 that is the average willingness to pay. So an owner with a price of $2,000 will have that car fetched for $2,200 to buyers, and anybody with a higher value to buyers won't actually sell at a price of $2,000, okay? Because the willingness to pay of, say, $2,300 by the buyers would mean that to the sellers, that's worth $2,100, but $2,100 is more than $2,000, so they wouldn't sell it. Okay, so we're getting a sort of a cutoff or a truncation in the number and the quality range in the market. At an average willingness to pay, there are a bunch of suppliers of cars who value it at more than that average willingness to pay who won't supply it. And in this case here, the cutoff point is for cars of $2,200 to buyers, they're not going to be in the market. Now, supposing that the buyers get to learn this, that eventually they learn that cars of over $2,200 are just not available in the market when the willingness to pay is $2,000. So they lower their willingness to pay. Now they're going to get somewhere between a car between $1,000 and $2,200. Halfway between that, an average is $1,600. So the willingness to pay drops to $1,600. Remember, it was up here at $2,000, but at $2,000, that was presuming that the whole range of cars was going to be out there from $1,000 to $3,000, and that's what got us our willingness to pay of $2,000. But then after that willingness to pay of 2,000, cars with more than 2,200 dropped out of the market. So now the average willingness to pay is going to be halfway in between there, which is 1,600. So now any seller with a car that's worth more than 1,600 is not going to sell it in the market. Those cars at 1,600 are worth 1,800 to buyers, and so the story goes. Okay, the cars that 1,800 are going to drop out of the market. We'll be left with an average willingness to pay between 1,000 and 800, 1,400. Then we got to worry about the owners of cars that are worth more than $1,400 to them, or the $1,600 to the buyers. And so the story goes. We get into this kind of vicious circle. And does it ever stop? Well, yes, it does. At a price of $1,200, if you work out the math. So this is the price that the owners will sell. Well, those owners will have qualities up to $1,400, and that will just match the willingness to pay of the buyers for a quality range from between 1,000 and 1,400. Halfway between there is 1,200. So at a price of 1,200, we stop this process where the buyers are exiting the market and the sellers are exiting the market, and the buyers are continuing to lower their willingness to pay. Now, it's a stylized example. It's pretty extreme. You know that buyers are going to be going out and doing inspections and getting warranties, and if they're not, the sellers are going to be trying to, distinguish their cars for the buyers. But it's really quite important to see that if there were symmetric information, perfect information, then a car of quality X, that is, X is like the willingness to pay of a buyer, say, $2,100, then there would be a seller out there who's willing to sell it at $1,900. And so there's a bargaining range that they can come to some kind of agreement, and all the different qualities would sell. There's willing sellers and willing buyers. But in this particular case, only 20% of the qualities actually trade. 80% of them are just not going to trade. And they're not trading because the market isn't kind of coordinating or the prices in the market are not coordinating the buyers and sellers because of this adverse selection problem, this asymmetric information problem. Now, the way around that is to come up with signaling or screening devices. Text, again, has some nice discussions of those, some of the numerical examples. The key idea, though, is that because of this adverse selection problem where the low quality drives out the good, there's a lot of bargains, transactions, exchanges that don't take place that would be in everybody's interest if they did take place. We've seen this kind of thing before with the Thursday's dilemma, not so much a transaction, but a situation creating where, lots of great mutually advantageous trades taking place, or that could take place there, but they're not, okay? We could all be better off, but we're not. Well, same with the average selection market, and there are ways of trying to redesign the game, which we look at in Chapter 10, or change the game to make it a more favorable one, and in this case for both parties. So we have there's going to be signaling actions and screening actions, with the signaling actions being where the informed party makes some effort to try to, or take some action to try to distinguish themselves and their product from others to sell in this case, to sell their product. Okay, and that'll be the people who aren't selling who would like to. And the screening kind of action is the people who aren't buying, who would like to buy. They'd like to buy a higher value car. They don't want this low-end sort of stuff, and they'll be going out and setting out, investigating or screening kind of devices. If you're trying to get information, the information doesn't have to be a screening device. It could be from a certification from an external authority like the AA, whatever. But the game will be changed, okay? But the lemons market captures in a stark form these problems of asymmetric information. Okay, we're going to have a look at the structure of a particularly simple signaling and screening game that's outlined on page 272, 277 of the text. As ever, we kind of go through who the players, what can they do, what's their information, and what are their payoffs. We have two types of players: employees, or potential employees, or potential applicants, and employers. There are two types of employees: the able guys and the challenged guys. Now, the private information comes because the two employees, or the two types of employees, know their own type. Okay. The things that an employee can do is to decide whether to apply for a job, and if they apply for a job, whether or not to take a set of courses that the employer has yet to decide upon. Okay, so in this game, the employer is going to be moving first, designing or setting up an educational screen, and the educational screen is in terms of how many tough courses are you going to take. So that's what X is. The other characteristic of the employees is worth knowing is how easy or difficult it is for them to do tough courses. This is not how easy or difficult it is for them to do the job, but rather if they have to take tough courses for a job, there's going to be monetary expenditures and time expenditures and effort expenditures, and we want to get a difference between the able guys to make it sort of cheaper overall for them to do a tough course than it is for the challenge guys. You can play around with numbers later on as to what happens when this difference between them is large or small, but for the moment we're going to follow the text and think that for an able person to do a tough course, the cost per course is $6,000. For a challenge person, C-type, it's $9,000 per course. Now, the idea here is not just paying fees, but taking time. And there's the opportunity cost of time. It's valuable to people. There's the problem of putting in effort during that time that's more or less difficult, and we're going to think less difficult for able than for challenge. And so we think it's a little bit easier or cheaper for an able person to do a tough course than it is for a challenge person. They can both do the course, but the challenged person is going to have to pay a higher cost to pass through the course than the able person. It's a higher personal cost. Okay, so ultimately what we want to do is look at the payoffs for the employees as whatever wage they get minus their total cost. And their total cost is going to depend on how many tough courses they take and the cost per course to each of them for taking those courses. Now, employers, they make profits. They get benefits from hiring effective employees. Both able and challenged people can be effective employees, but one more so than the other. So the employers are willing to pay up to $150,000 for an able employee, and for the C-type employee, they're willing to pay $100,000. Okay, so this is America. Wages a little bit higher. It's not New Zealand, but we can all live in our dreams, right? Whether you're able or challenged. Now, the employer is in a position of uncertainty about what the type is of the employee. And they are well aware of these adverse selection problems and the problem of the low quality driving out the good and having to pay just sort of average wages. And they don't want to do this. They want to try and come up with a way of separating out the different types of employees and letting the employees decide. Okay, so this is their scheme. It's called a screening game or an educational screening game. They're going to set up a number of courses that are observable, the number of courses being observable to the employer. They know that these are tough courses, and on the basis of these tough courses, they're going to decide to pay a wage. Okay? The employers are going to pay a high wage if you've got a large number of courses, and is the number of cutoff or number of courses at the cutoff. And if you've got a small number of courses, then you're going to get paid a low wage of $100K. So the idea is that the employers, though they can't see the type, that is the ability of each of the employees, they can set up an educational sort of screen that says anybody who gets past N courses, I will pay them a high wage, or I will regard them as if they were an A-type. Could be wrong, could be right, but I'm going to pay them $150K. All right, and if you take less than N courses, I'm going to regard you as a C-type. Again, could be wrong, could be right, but I'll only pay you $100K. So here, the wage agreement or wage contract is like a menu. The employees, basically, the employees have to decide how many tough courses to take. Okay, none, 1, 2, 3, whatever. Okay, and let's have a look at their incentives. Remember, what we're trying to do is to come up with a way of screening out the able types from the challenge types, and we can't observe their type, but letting their choices about the number of courses they take reveal what their types are. So let's look at the problem from the perspective of the C-types. The C-types don't like taking tough courses, okay, but they might be willing to get their high net payoff, which is the difference between their wage and their total cost. So On the left-hand side of this inequality, we have the number 100, which is the salary that will be paid to someone who takes a small number of courses. Okay, so by taking a low number of courses, in this case 0, you can get the full salary of 100,000. On the other hand, supposing you take n courses, so n and x is equal to n, and that means you get paid 150. Your wage is 150, but because you have the high personal costs of 9,000 per course, you've got to subtract off your total costs. And let's say you took one course, it would be 150 minus 9, or 141,000. If it was 2 courses, it would be 150 minus 18. If it was 3, it would be 150 minus 27. That would be your net payoff. Now we put the inequality this way here because we're really thinking in terms of best responses. We want a number n, that is the number of tough courses to take, so that the challenge type's best response, or their preference, is not to take any courses at all, rather than take the n courses and get access to the higher wage. Okay, well, stick with me here, and let's keep going to the A-types. For the A-types, what we want them to do is to take the courses. That is, to get the higher wage, they have to take in courses. That's 150,000. But their costs are 6,000 per course, so multiply times the number of courses, that's the total cost. So one course is 6,000, 2 courses 12,000, 10 courses 60,000, okay? And this is their net payoff from taking the courses and getting the higher wage. This 100 is the net payoff they get. If they don't take any courses, they get treated like an able type, and they get paid, or a challenge type. They're not, but they get treated like one, and they're paid 100K. Okay. Now, the inequality here, so the left-hand side is their net payoff from taking the courses is greater than the payoffs that they would get without taking the courses. Now, these two conditions are really best responses of the two different types of agents, right? And we call them incentive compatibility constraints. They're really just ideas about best responses given the constraints that they face, or the choices they face, which in this case are to decide how many courses to take. Now, we've set this up kind of hypothetically in that we're looking for a number n of tough courses, and that will satisfy the incentive compatibility constraint for the C types and the incentive compatibility constraints for the A types. It turns out that if you solve these two inequalities together, you come up to figure out that n must be less than or equal to 6, or less than or equal to 8, or greater than or equal to 6. I mean, if you can't solve the inequalities, you can take guesses, okay, to get an idea. So let's just take a guess at n equals 5, see why it doesn't work. Okay, well, if we have n equals 5, then the cost to the challenge type is 9 times 5 is 45,000. Their benefit is 105,000. That's if they take the courses. They're going to get the higher wage, subtract off the cost of taking the courses, and their payoff is going to be 105,000. But 105,000 isn't less than 100,000, so this inequality wouldn't hold if n was equal to 5. Okay, we wouldn't satisfy the incentive compatibility constraint. We wouldn't have a best response for the C types, the challenge types of not taking the courses if n is equal to 5. For a low number of courses, it's going to be worth their while to take the tough courses, pay the costs, and get access to the higher wage, rather than not and just get 100. So you have to have n greater than 5. Now, it turns out that if we plug n equals 6, or n equals 7, or n equals 8 into these equations, both the inequalities to be satisfied. What we mean by that is both incentive compatibility constraints to be satisfied, which means that the A's best response will be to take the course, and the C's best response will be to not take the course, and their choice then will reveal their type. Now, when we can find such an n, we'll call it a separating equilibrium. It turns out there could be numbers where it wouldn't be possible to find such an n. You can play around with that yourself, okay? But the idea here is that we have found a variety of n's, n equals 8, n equals 7, n equals 6, that mean that the choices of the individuals involved reveal their type. The strategies of the individuals reveal their type. That is, if you're an A type, you're going to choose to get educated, pay the 6 times 6 is 36,000 in cost. Your net payoff is 114. That's better than 100 you could get if you didn't get educated. The C types, though, for n equals 6, their net payoff is, if they take the courses, is 150 minus 9 times 6 is 54, so that's 96. That's less than 100, and it's not worth it, so they won't take the tough courses, and their payment will be 100. And we call it a separating equilibrium because it separates out the types. If we don't find an n in that range, then what's going to happen is, if the n is too small, then everybody's going to go through the tough courses and get educated, and if n is too big, nobody's going to get educated, and then the screen won't separate out the two types. It may be that there's what's called a pooling equilibrium, which is discussed in the text, where the everybody gets paid the same wage, and that they all get the education, or everybody gets paid the same wage and none of them get the education. So in the text is the discussion of these pooling equilibria. Now, one property of this particular separating equilibria, going back to it, is that we have this equilibria. People are incurring, the A-types in particular are incurring large education costs, but it's really, the education isn't doing anything for their productivity. Their productivity is still $150,000 to the firm, whether they take this education or not. So it's an important thing to remember here. There's costs of education that are being incurred, but those costs aren't improving anybody's productivity. All they're doing is adding and they're reducing the net benefits that the able types get. And if you like, these are costs of the imperfect or asymmetric information. If everybody walked around with an A label on their forehead or a C label on their forehead, we would expect the bargains to be struck, so the A-types would get paid the higher wage and the C-types would get paid the lower wage. There wouldn't be any choices about that because involved, because as a C-type you can't pretend to be an A-type with a label on your head, and as an A-type you don't want to pretend to be a C-type when you got these labels on your head. Okay, so that's the concept of a separating equilibria. As I said, you might wonder, is there a pooling equilibria? Could we ever have a common wage for both types? And what we would want is that to be an equilibrium, a Nash equilibrium, in the sense that each player is making a best response to the choices of the other player, right? And the text has a very good argument as to why we're not going to be able to get a pooling equilibrium at a common wage here. Either the able people say they get pooled at the low end, then somebody who's able can put up their hand and try and bargain for an improvement in their wage. There'll be some employers that will take that up because it'll be profitable. The other firms will imitate them and will work their way back towards the separating equilibrium.